Welcome to Chapter 7 Ionic Equilibria, Buffer Solution. Let's learn how to describe how a buffer solution controls its pH. Okay, so the acid components of a buffer can neutralize a small amount, remember, small added amount of base, and then the basic component can neutralize the small amount of added H3O+. Okay, so first of all, you must remember one thing, that is, okay, if let's say this is an acidic buffer solution, then it contains a mixture of weak acid and conjugate base. Okay, so now let's move on. Okay, so when you have small amounts of strong acid added, okay, so what happened? Okay, so when you have small amount of acid added, so we have weak acid and conjugate base. Okay, so I will use this part now. Okay, so you have weak acid and conjugate base. So if it's acid, acid will react with base. Okay, so when acid react with base, it is a neutralization. Then it will produce CH3COOH, okay, and also H2O. Okay, or you can just write CH3COOH. Now, what happened here is H plus will completely consume because it is small amount, so it acts like limiting reactant. Okay, since conjugate base here is a reactant, thus the concentration after the addition of strong acid, the concentration of conjugate base will decrease. And then weak acid is the product now, so the concentration of weak acid will increase. Okay, so remember the ratio here refers to the Henderson-Hasselbalch, that is conjugate base over weak acid. So our conjugate base here decrease, and then at the same time weak acid increase. Thus there's no significant change in the ratio of conjugate base and weak acid. That is why we say that the pH of the buffer solution maintained even after small amount of strong acid or strong base is added. Okay, how about strong base? Remember, it must be small amount of strong base added. So at this time, if we have base react with acid. Okay, so base react with weak acid. So what happens is it will produce conjugate base. Okay, and this so means that the concentration of weak acid after the addition of small amount of strong base, which react as like limiting reactant, so it will at the same time it will decrease, weak acid decrease, and then conjugate base as the product will increase. So the ratio 1 increase, conjugate base increase, and then weak acid decrease. So it does not change significantly. So this is how a pH of a buffer solution maintained after small amounts of strong base is added. And then remember, look at here, this is a Henderson-Hasselbalch equation, so it is not log product over log reactant. It is conjugate base over weak acid. Okay, so this is in terms of words. So when we want to explain, okay, so you have to explain first part, that is the neutralization. Okay, so you must explain what happened when small amounts of strong base or small amounts of acid is added to the buffer solution. Okay, then after that, you have to mention about the ratio remain more or less constant, and then show the ratio. Okay, then finally, you have to mention that the pH is not significantly changed. So this is how you explain it. Okay, now how about a basic buffer solution? Maintains its pH. Okay, so remember a basic buffer solution contains a mixture of weak base and conjugate acid. Okay, now I will use this part. Okay, let's say you have small amount of strong acid added. So acid will react with base. Okay, so what happened here is neutralization occurs, means that weak base here react with acid. So this is the conjugate acid. So because ammonia is the reactant, so ammonia concentration after neutralization decrease and conjugate acid increase. Thus, the ratio does not change significantly. So the pH of the buffer solution maintains even after strong acid is added, a small amount of strong acid is added to the basic buffer solution. Okay, if you add strong base, so base will react with acid. Okay, so this is the conjugate acid, NH4 plus, and then react with base. So what happens after the neutralization is conjugate acid decrease and then weak base increase. So the ratio does not change significantly, and this is how the buffer solution maintain. Okay, so for the explanation part, it is the same. Okay, talk about the neutralization and then mention about the ratio, which is constant, and then mention that pH does not change significantly. So that is how you explain how a buffer solution maintains its pH. That's all for this part.